In this video, we'll be solving a question on gravitational fields. So the question says, it is suggested that a mass of a mountain could be measured by the deflection from the vertical of a suspended mass. The diagram shows the principle. Copy the diagram and draw arrows to represent the forces acting on the mass, and it says label the arrows. So this is the small mass here, and this small mass here, okay, is going to experience a gravitational attraction due to the mountain. So I'm going to draw the mass here. This is the 20 grams mass. Now it's going to experience a gravitational attraction towards the mountain because mass attracts mass. Then it's going to experience a tension force. So a tension force will be exerted. So I'm going to write tension. Then I'm going to write the gravitational force due to mountain. And then I'm going to write the weight, which is basically the force, the gravitational force due to Earth, which is basically the weight. So these are the three forces that you have. And that's for 3 marks. Now the second part says that the whole mass of the mountain is 3.8 times 10 to the raised power of 12 kg and may be considered to act at its center of mass. Calculate the horizontal force on the mass due to the mountain. Okay. So what I'm going to do here is we're going to have this. We have an angle theta, and then we have the mass here, and we want to find the horizontal force. We want to find this force. I want to find this force right here, and we can find this force very easily. This is the gravitational force, gravitational force between the mass and the mountain. So it's going to be Gmm over r square. So G is 6.67 times 10 to the raised power of minus 11 times. I'm going to consider the mountain as a point mass. So this is going to be the mountain. My bad for that. And this is going to be the mass of the, let's think it's a ball. Mass of, let's just call it a ball. Okay, let's go for the ball. Mass of the ball. And then the mass of the mountain. Okay. So then what I'm going to do is I'm going to plug in the values. So there we have plugged in the values, and we should get an answer of 3.52 times 10 to the raised power of minus 6 newtons. Right. Okay. That's the first part B. Now let's see part C. Part C says compare the force calculated in part B with the gravitational force due to Earth on the mass. So we want to calculate the force that is exerted by the Earth. So we want to find this Fg here. So this is by Earth. You can calculate it as Fg is equals to Gmm over r square. Okay. So it says compare. So we are supposed to explain it. Now let me first explain it. Okay. So let's explain it first. The gravitational force due to Earth will be greater than due to the mountain. This is because the mass of the Earth is significantly greater than mass of the mountain. Okay. Let's find the gravitational force, which is going to be Fg is equals to Gmm over r squared. Now I'm gonna ask you a question. Do we know the distance from the mass to the Earth's center? We don't. Because of that, we can't really use this formula. But we can use another formula. We know that this force is also equals to mass times g. We know that the gravitational field is just the force exerted on a mass. So F is equals to mg, which is also equals to the weight. So now what we can do is we can say 20 times 10 to the raised power of minus 3 times 9.81. That's going to give me the force. That's going to give me 0.1962 newtons. Okay, so that's the answer to that question. Now, I'm going to make up another part. Part D. Let's make part D. Part D says find the tension and theta. So we have the mass here. This force was given to us as 3.52 times 10 to the raised power of minus 6 newtons. This force is 0.192, 1962 newtons. Tension T, and then we have this angle as theta. So right off the bat, I can say that this angle is also theta, the alternate angles, and I can resolve the two components. So this is going to be T cos theta, and it's going to be T sin theta. 3.52 times 10 to the raised power of minus 6 newtons. I'm going to say that given, I think it should be in equilibrium. If it's not, then I'm going to say it's in equilibrium. A mass is suspended. Okay, we're going to assume that it's in equilibrium then. Okay, so it's in equilibrium, and this here is going to be 0.1962 newtons. So the horizontal and the vertical forces are balanced because it's suspended and it's in equilibrium. And then we can say that T cos theta is equal to 0.1962 and T sin theta is equal to 3.52 times 10 to the raised power of minus 6. We can divide both sides and we'll get T cancelled out. Sin theta over cos theta is tan theta is equal to 3.52 times 10 to the raised power of minus 6 divided by 0.1962. You can find the theta value. So I'm going to get a very small theta value at 1.027 times 10 to the raised power of minus 3 degrees. And then we can find the tension through this as well. So we can that T cos theta is 1.0279 times 10 to the raised power, 9 here as well, minus 3 is equal to 0.1962. So T value I'm going to get as 0.196 newtons. Okay, so that's the answer to this question.